An independent editorial defense analysis focused on Australia's strategic environment.
The scent of diesel, the rattle of tracks. For 6 decades, these have defined the Australian Army's mechanized identity. Yet the most significant evolution in its armored capability is currently taking place in silence. Deep within the test ranges of the Northern Territory, M113 AS4 armored personnel carriers are maneuvering. They are moving through complex terrain without a single human operator on board. This development represents far more than a technical curiosity. It is not merely a recycling program for obsolete hardware. Instead, it signals a fundamental shift in Australian military doctrine. It moves away from a purely human-centric force structure toward an integrated system. A system where legacy platforms are repurposed to solve the acute strategic dilemma of mass versus modernization. The transformation of these Vietnam-era vehicles into autonomous systems offers a window into how the Australian Defence Force attempts to bridge the gap between its ambitious strategic reviews and the fiscal realities of procuring next-generation combat power. At the heart of this initiative lies a stark numerical reality generated by the Land 400 Phase 3 program. The decision to acquire 129 AS21 Redback infantry fighting vehicles marks a leap in lethality and protection, but it simultaneously creates a significant reduction in fleet density. Replacing over 400 M113s with fewer than 130 Redbacks results in a capability gap that cannot be ignored. While the Redback offers superior survivability, a defense force cannot be in 2 places at once with a single high-end asset. This reduction in hull numbers necessitates an innovative approach to force generation. The conversion of the M113 fleet into optionally crewed combat vehicles serves as a force multiplier. It allows a smaller number of expensive, manned Redbacks to control a larger number of expendable, autonomous assets. This concept, often termed manned-unmanned teaming, allows the Army to project force across a wider frontage without exposing its limited human personnel to initial contact. The industrial logic behind this conversion is equally critical. BAE Systems, Australia, in collaboration with the Robotic and Autonomous Systems Implementation and Coordination Office, has focused on a retrofit approach. By utilizing the sunk costs of the M113 fleet, the Australian Army is effectively creating a low-cost testing ground. The strategic value here is not necessarily the hull itself. It is the sovereign development of the software architecture. This distinction is vital. If Australia were to simply import foreign robotic systems, it would be reliant on external supply chains for software updates and algorithmic adjustments. By developing the brain of the vehicle domestically on the M113 chassis, Australia avoids the black box problem. It ensures that Australian industry retains intellectual property rights over the critical guidance systems. This allows for rapid code modification in wartime, a capability that could prove as decisive as ammunition stocks. Operationally, the deployment of these robotic platforms addresses the concept of attritable mass. In a high-intensity conflict within the Indo-Pacific, but the loss of a fully crewed infantry fighting vehicle is a tactical and political disaster. The loss of an unmanned M113 is merely a logistical statistic. These ghost vehicles can be assigned the most dangerous tasks: breaching minefields, drawing enemy fire to reveal concealed positions, or conducting resupply missions through contested zones. This fundamentally alters the economic calculus of the battlefield. It forces the adversary onto the wrong side of the cost curve. Expending a sophisticated, multi-million-dollar guided missile to destroy a decommissioned transport vehicle is a poor strategic exchange for the enemy. But it is a winning trade for the Australian commander. This changes the risk calculus. Instead of hesitating to commit forces due to casualty aversion, a commander can push a screen of autonomous M113s forward to develop the situation. The limitations of the older chassis become less relevant when human safety is removed from the equation. However, relying on converted legacy platforms introduces complex trade-offs. Regardless of its new brain, the M113 retains the physical limitations of its 1960s design. Its aluminum armor offers negligible protection against modern munitions. There is a valid systematic concern that the Army might be investing in a fleet of robots that could be neutralized too easily. If the platform is destroyed before it can deploy its sensors or offload its supplies, the theoretical value of mass evaporates. Furthermore, this transition imposes a new cognitive burden on the Australian soldier. It is no longer enough to be a marksman or a driver. The infantryman of the future must become a systems integrator. Managing a swarm of semi-autonomous vehicles while operating their own platform requires a level of mental agility that current training pipelines are only beginning to address. The M113 project serves as the classroom for this new curriculum. It allows mistakes to be made with expendable hardware before the stakes are raised with future, purpose-built robotic combat vehicles. There is also the reliance on electronic tethering. This exposes the formation to electronic warfare. If a peer adversary successfully jams the control frequencies, the autonomous fleet risks becoming a static obstacle rather than a dynamic asset. The integration of these systems requires a robust, jam-resistant network that Australia is still in the process of hardening. Beyond the technical, there is a significant opportunity cost regarding the allocation of these hulls. The ongoing conflict in Ukraine has created an insatiable demand for armor. Every M113 retained in Australia for robotic conversion is one less vehicle available for immediate military aid. This creates a tension between diplomatic utility and long-term capability development. The decision to keep a portion of the fleet suggests that acquiring institutional knowledge on robotics is viewed as a priority that rivals immediate foreign aid requirements. From a sustainment perspective, the continued operation of the M113 fleet imposes a logistical burden. Maintaining a supply chain for vehicles that have been out of production for decades is inefficient. The engine, the transmission, the suspension systems. These require specialized maintenance that diverts resources from the newer Boxer and Redback fleets. Consequently, the Ghost fleet is likely a transitional capability. It serves as a bridge to the 2030s and 2040s. The program allows the Army to write the doctrine for robot warfare today, rather than waiting for the perfect machine to arrive tomorrow. The trajectory of the M113 AS4 program indicates a subtle but profound maturity in Australian defence planning. It acknowledges that in an era of constrained budgets, the pursuit of cutting-edge technology must be balanced with pragmatic adaptation. By turning a liability into a laboratory, the Army is attempting to solve the problem of mass without bankrupting the personnel budget. Whether these aluminum veterans can withstand the rigors of modern combat remains an open question. But their conversion underscores a recognition that the future of the Australian Army will likely be defined not just by the quality of its armor, but by the sophistication of the algorithms driving it. The ultimate value of the Ghost fleet may not be in the battles it fights, but in the data it generates, shaping the requirements for the true robotic combat vehicles that will eventually take their place. This is not just about extending the life of a machine. It is about birthing a new way of war.